So an exam's coming up, so let's review essentially today, because we've covered everything from the Chapter 4C questions that's due Sunday. The discussion's due then as well. Looking at the discussion, I've got a lot of feedback with the homework. A lot of people were having troubles with the McGraw-Hill, the Connect homework, just with the formatting of it. They were finding difficulties in it. So what I'm going to do for the remainders of the chapter, as long as I get positive feedback, is instead of assigning the McGraw-Hill questions, I'm going to make a homework question set kind of like the exam questions. So it's on Blackboard, multiple choice and fill in the blank. You'll still get 3 attempts. You'll get some feedback. It won't be as intensive as the McGraw-Hill, and what I mean by that is how they have all those features, like solve the problem, check your work. We don't have that available in Blackboard, but I do have, once you take it and submit it the first time, you can have feedback work that I type in. So you'll get some feedback on it. So if people prefer that way, I'll do chapters 5 through 9 that way. If a lot of people aren't liking my Blackboard homework, I'll switch back to the Connect. So the discussion's really helpful for that, or emailing me to let me know what you prefer, and majority rules. So the loudest people win, so give your opinion. With that, the exam on all of Chapter 4 is going to be due Wednesday. So we're starting the review today. I'll do another review on Monday. So if you don't want to take it before Monday, that's fine. It's not due till Wednesday. However, you will see it open on Sunday. So if you prefer to take it Sunday, you can, but I will have another review Monday if you want to wait. It's 28 questions and a 2-hour time limit. So that's all for announcements of what's due in the near future. So what we're going to do today is I've posted a review with 9 different review questions. And what I'm going to do before we approach them, or before we solve them, instead of me just going through and solving them, is I'm going to go through each of the problems and kind of explain how to start them. Because there's been feedback in the discussion as well that people are there's so many different types of problems, like, where do I start? I know I need to make a plan, but what do I start with in my plan? So for the first one, it's asking about solving for atoms. Okay. Now I know I'm seeing the reason why it's tricky to start is because there's so many different types of atom problems. So if they're asking you to solve for atoms, and the only thing given is a chemical, so there's 3 types of atom problems I'm going to talk about. One of them is if they give you a chemical formula. Okay, an example being C3H12O6. So the question says, okay, how many atoms are there given this chemical formula? So how do you approach that? Well, if the only thing they gave you is the chemical formula, the number of atoms is going to be the subscripts. So when they're talking atoms, they're talking the subscripts after each of those elements. Okay, so to solve a problem like this, it would be, all right, how many atoms? Well, there are 6 carbon atoms, 12 oxygen atoms, and then the subscript on, oh sorry, not 12 oxygen. Look at me, I got that wrong, 12 hydrogen. So the subscript is the number of atoms of the element preceding it. So 12 hydrogens, 6 oxygens. So that's just one type of atom problem. The one in number 1 is asking atoms again, but it's asking atoms given a balanced chemical equation. So if the question is asking for atoms and it gives you a balanced chemical equation, you're doing something similar. You're going to be using the subscripts, but you're also going to be using the coefficient. So for this one, you need to do coefficient times subscript. So let's look at what example of that. So now I gotta come up with a balanced chemical formula. I've used this one before. It's stuck in my head, so hopefully we've done it. 2. Wait, should be 4. Trying to make sure it's balanced. We got 4, we got 4. We got 6, we got 6. Okay. So they would give you a balanced chemical equation, and they would say, okay, how many atoms of aluminum and how many atoms of oxygen? So this is very similar to the actual number 1 that we have. So in this case, you can't just use the subscripts because the coefficients in front of them are telling you how many of that element or compound as well. So if I were trying to figure out how many atoms of aluminum, and it doesn't matter, which is nice, it doesn't matter what side you use, because in a balanced chemical equation, you should have the same number of atoms on both sides of the equation. So I have 4 aluminums, 4 times the subscript of 1, 4 times 1 tells me I have 4 aluminums. If I use this side instead, I should still get 4, coefficient of 2, coefficient times subscript of 2, 2 times 2 tells me 4. Now for oxygen, how many do we have? Coefficient times subscript, 3 times 2, 6. So I guess what I'm trying to get at is when they ask you how many atoms, you need to look at the clues in the problem to see, okay, what are they giving me to figure that out? So here are 2 of the types of questions of atoms. There's a third one. If they ask how many atoms, but instead of giving you a chemical formula or a balanced equation, instead they say how many atoms in 3.2 moles of aluminum. Okay, draw this in blue. Here are 3 types of atom problems that we'll see in this exam. Atoms given the chemical formula, how many atoms of each element given the balanced chemical equation, in which you take coefficient and subscript. Third type might be how many atoms if they give you moles, or if they give you grams. Okay, so here, if they just gave you aluminum, that would be 1 atom of aluminum. But they're telling you, you don't have just 1 atom, you have 3.2 moles and go to atoms. So, this type of atoms, we are going to be using Avogadro's number. So if they give you a molar amount, a gram amount, and then ask for atoms, Avogadro's number is going to be used at some point in there. Because Avogadro's number, that's 6.022 times 10 to the 23rd, can't write today, 23rd. This is atoms, when we're talking about an element, in 1 mole of a substance. This was the definition of a mole. When we first talked about Avogadro's number, the definition of a mole was that a mole of anything, whether it be an element or a compound, it's going to have 6.022 times 10 to the 23rd atoms in it, or molecules in it, or formula units in it. Okay, so you're going to have to use this at some point. I'm going to erase this top part because I want to explain exactly the steps you'd use, whether it was a moles or gram amount given to you. So, usually we do the dimensional analysis way, the railroad track way, and we use this as a conversion factor and try to figure out where to put it, what cancels out. Are we dividing? Are we multiplying? What I'm going to do is I'm just going to give you an equation you can use if you don't, that you can memorize or write down and have handy if you don't want to figure out the railroad track method. So figuring out the number of atoms when you're going from moles to atoms. The equation would be atoms is equal to moles. Now I have to set it up in my head. Multiplied by 6.022. So to figure out the number of atoms, you need to take the mole amount given to you in the problem and multiply by Avogadro's number. If you are trying to figure out the number of atoms from grams, it's going to be 2 steps. You're starting with grams, so you have the gram amount, and then molar mass is grams per mole, so we're going to have to divide that by the molar mass, and then multiply that by Avogadro's number. So that's the process. So to show you, given this example, it's asking how many atoms. If I have 2.1 grams, I would start with my gram amount. I'm dividing by my molar mass, which is grams per mole. That's why I'm dividing by the molar mass, because I need the grams on the bottom. And then multiplying by Avogadro's number. So for multiplying, it's going to go on top, which will put the 1 mole on the bottom. So this is the railroad track method, but if this isn't jiving with your, just write this down, and when you get to a problem that asks for atoms and they give you grams, know, okay, I'm going to be dividing by whatever the molar mass is, and I'm going to multiply by Avogadro's number. Because that's essentially what we're doing when we do the railroad track method. All right, so those are the 3 types of atoms problems you'll see. To figure out how to approach them, you need to look. Do I have a chemical formula? Or do I have a balanced chemical equation? Or do I have a molar gram amount? From there, use one of those 3 methods. All right. Let's look at the next problem. And some of these might be overlapping as we go through the review problems. For number 2, how many moles of nitrogen are needed to react with 1.5 moles of hydrogen? All right, so number 2, now we're looking at moles. So there's going to be several different types of mole problems. Hopefully I can think of all of them off the top of my head here. So to solve for moles, once again, you have, just like with the atom problems, you have to look, what are they giving me? Okay, so if they're asking how many moles, and they give you a balanced chemical equation, you need to remember, with balanced chemical equations, the coefficients represent the number of moles. So there are 4 moles of aluminum reacting with 3 moles of O2, producing 2 moles of aluminum oxide. Those coefficients represent the number of moles. If they're asking you to go from moles of one compound to moles of a different, you're going to be using the mole ratio of the two. So find which two they're asking you to compare, and since the coefficients represent the number of moles, you're comparing the coefficients of those two. For example, say you have 1.5 moles of aluminum. You're saying how many moles of aluminum oxide will be produced. So for a question like this, they're giving you a balanced chemical equation. So you know that the coefficients are going to represent the moles. More specifically, they're going from moles of one compound, aluminum, and asking for moles of a different compound. So you're going to need to use a mole ratio using those coefficients. How do you know what coefficients to look at? The two elements that they're comparing in the question are the two coefficients you're going to compare in the balanced chemical equation. So the mole ratio is going to be 4 to 2 in this case because it's aluminum and aluminum oxide. This one I don't have a shortcut for. You have to do the railroad tracks and see how it goes. When you do the railroad tracks, you always start with what is given in the question itself. So it would be the 1.5 moles of aluminum. When you're using the mole ratio, you're trying to get away from aluminum, trying to get rid of it. So you would use the moles of aluminum, the coefficient of 4 would go down here, because that represents aluminum. And then the 2 would go up here, because that represents aluminum oxide. What is 3 divided by 4.75? So this is just one type of mole problem. There is 2 more types that I can think of off the top of my head. So let's look at those. So if you aren't given a balanced chemical equation, instead you are given an atom amount, or a molecule amount, or a gram amount. Okay, so this is where they're giving you numbers instead of a balanced chemical equation. So they're asking how many moles, and you are given atoms, molecules, or formula units. That's what FU stands for, not what you think it does. Formula units. Okay, so you're given atoms, molecules, or formula units. It's all approached the same way. For this one, you're going to take the atom, molecules, or formula units that they give you. You're solving for moles. So moles are going to equal whatever atoms, molecules, or formula units they give you. That'll be, I need to do it the railroad track method, and I'm trying to come up with equations not using the railroad track method, so just give me a second here. So this would be atoms per mole. Okay. So, I'm trying to figure out moles, right? You would have to take atoms, you have to divide by. I need a problem to figure out the equation. So let's say they say how many moles, this will help me, sorry. divide 2 times 10 to the 24 atoms. Okay, so if you're given the amount of atoms, whenever you have atoms in a problem or molecules in a problem or formula units in a problem, you're always using Avogadro's number. Okay, so anytime you see one of these words, Avogadro's number will be used at some point. So what is Avogadro's number? 6.022 times 10 to the 23rd. And that's equal to 1 mole. Now the unit that's usually here by this giant number is particles, is the word they use. The reason they use the word particles is because particles can be atoms, particles can be molecules, or particles can be formula units. So whatever the question is using, that's what your particles are. So my particles are atoms. So to solve this problem, we're starting with the atoms given, and you're dividing by Avogadro's number. So this is dimensional analysis way.
Is the 24 in the question?
Oh, 24, thank you. 24. So that's the dimensional analysis way, but if you want to write it as an equation, if you're solving for moles, you can take the number of atoms given and divide by Avogadro's number. So if it's saying how many moles and it's giving you the atoms, you would put the atoms here and then just divide by Avogadro's number. So this could be an equation you could write down. And when you approach that problem, know, okay, I'm just going to take this amount of atoms and I'm going to plug it into this equation if you prefer the plug and chug method. The other type, so instead of being given atom, molecules, or formula units, but you are given grams. It's going to be a two-step one. Move this question up, then I'll just switch it. How many moles in in this one, they're asking for moles again, but this time they're giving you grams. So we'll do the dimensional analysis way first, because that's the way that makes sense in my head, and then I'll come up with an equation for you to plug in and chug with. So if I try to just come up with an equation, it kind of gets messy. So when you are starting with grams, we need to, and we're going to moles. To go between grams and moles, we need molar mass. Every time. Grams and moles, we need molar mass. So, molar mass of what? You look at either the element or compound that they gave you in the question. In this case, it's just an element, so there's no side calculation needed. We can just find the molar mass of carbon on the periodic table. And it is 12.011 grams per mole. That's the only piece of information I need. I start with what they give me in the problem. In this case, I'm dividing by molar mass. So, if you wanted a plug and chug equation, if you were solving for moles and you were given grams, you would divide by whatever the molar mass is. So this would be the equation to plug. You would plug in the grams from the question itself and divide by the molar mass, which you would have to figure that out based off of the element or compound given in the question. So here's the equation if you do not prefer the railroad track method for that type of problem. All right, mole ratio we already talked about. Mole ratio again, mass in grams. So we've covered all the atoms, I guess we haven't covered grams yet, so let's cover that one. We've covered all the atoms ones, all the moles ones, we'll cover the gram ones, and then we'll start doing this worksheet. So, we looked at problems that are asking you to solve for atoms and problems that are asking you to solve for moles. Now what if they're asking you to solve for grams? So what types of problems will you see asking for grams, and how do you solve them? So one would be if they give you moles, and you need to solve for grams. So it's similar to the last one because we're going between moles and grams again. It's just the opposite direction this time. So if you're going between moles and grams, you still need molar mass. Notice in the last one though, we divided by molar mass. Since we're going the opposite direction this time, instead of going from grams to moles, we're going from moles to grams, we're going to multiply by molar mass. 0.521 moles. Molar mass of oxygen, 32. So, and we just said you're going to multiply, so you put the 32 on top. So the equation would be, if you're solving for grams, or if you're solving for mass, which is grams, you're going to take the amount of moles given and multiply it by the molar mass. So all these equations that I'm kind of making up on the side, you can just write a list of them that are ready for the exam if you think this method is going to help you more so than trying to figure out what goes on top and what goes on bottom for the railroad track method. Okay. So what if they want you to solve for mass, but you're given atoms? So I should say atoms, molecules, or formula units, because they're all going to be solved the same way. How many grams? So they give you the number of atoms of copper, for instance, and they ask how many grams. So whenever you see the word atoms, molecules, or formula units, what are you most likely going to be using? That Avogadro's number. Okay, so that's going to be used at some point. For a problem like this, you're going to go from atoms, or molecules, or formula units, to moles, and then to grams. You can never get from atoms to grams directly. You always are going to have to go from moles to moles first. Whenever you are going from atoms to anything else with a numerical value, it's going to be Avogadro's number that you're using. Whenever you're going from moles to grams, it's going to be molar mass. No matter what direction molar mass we use somehow, you just need to figure out, are you multiplying by molar mass or am I dividing by molar mass? So I'm going to do the railroad track method, and then I will get an equation written over here. So we're starting with atoms. We have Avogadro's number, which is atoms equal to 1 mole. So we're dividing by Avogadro's number. And then, this step, we need molar mass. So where's copper at? 63.5. 63.5 is the molar mass of copper, and that is grams per mole. So 63.5 grams is equal to 1 mole. So we are going to be multiplying by molar mass, right? Because I need the grams in the top so the moles go on the bottom. 63.5 grams. Okay, so my equation. I'm solving for grams, mass. And I'm given the amount of atoms. So I'm going to start with my amount of atoms. I'm going to divide by Avogadro's number, and then I'm going to multiply by the molar mass. So that would be your plug and chug equation. You take the atoms given in the question, you divide by Avogadro's number, the 6.022 times 10 to the 23rd, and then multiply by the molar mass using the element or compound given in the question. I will try to get all of these equations kind of condensed and written up on a sheet for you to have access to during the exam, if you think this will help. But if the railroad track method is working for you, ignore this. It's just, everybody learns differently, and different methods make sense to them. So pick what sticks with you, what makes sense to you, and leave what doesn't. All right. If you have any other questions or a specific type of problem that you're just not understanding how to start, please email that to me so that I can address that on Monday. But for now, what I'm going to do is start working through these problems using the equations that we came up with, but also the railroad track method, so that I'm applying to all audiences. All right. Don't forget about the practice exam that I have posted. There's an answer key. It's not a practice exam via Blackboard. It's just a paper copy, so you can print it out and work on it. I saw not a lot of people took the Blackboard one that I posted for the last exam. So I wanted to give one that had an answer key, so at least if you weren't going to do it, you could see the answers. Maybe work through it that way. Or have a printout ready for you when you take the exam. So let's start the review with actual number 1. So in number 1, it says, when the following reaction is balanced, there are blank atoms of oxygen and blank atoms of hydrogen. So this is one of those atoms problems. Okay, so it's an atom problem, and they are giving us a balanced chemical equation. Actually, they're asking us to balance it first. But in the end, we're going to be figuring out the number of atoms based off a balanced chemical equation. So for this type, to figure out the atoms, we are going to take whatever coefficients we come up with and multiply it by the subscripts for each atom they're asking for. So let's start I have a feeling this is the only one we're actually going to get through today. By balancing it. Let's do it all, actually. I mean, if we're practicing for the exam, let's see what type of reaction it is. Let's predict the products. Let's balance it. Let's do it all. This would be several different questions on the exam, but it's good practice. So we have a carbon-hydrogen compound reacting with oxygen. So what type of reaction is that? Combustion. Whenever you have a compound that has carbon and hydrogen in it, reacting with pure oxygen, this is the fuel, it is a combustion reaction. When we have a combustion reaction, what are always the two products? Water and CO2, always, those don't change. So, we have the type, we predicted the products. In order to figure out the number of atoms, we need to balance it. We need a balanced chemical equation. So let's start doing that by making our list. Carbon, hydrogen, oxygen. So when we say balancing, we're looking for the same number of atoms on both sides. And that will help us figure out how many atoms once we balance. So we have carbon, hydrogen, oxygen. I just write them in the same order so I can compare them better. It's up to you how you do it. All right. We start by counting how many there are at the moment using just the subscripts. So how many carbons do we have on the reactant side? 2 hydrogens. And then oxygens are tricky, they're in 2 spots. 1 plus 2, total of 3. Okay. The other side. 1 carbon, 2 hydrogens. Oxygens are tricky again. 1 plus 2 is 3. Hey, at least our oxygens are balancing. I'm sure that's going to change in a minute, but. So with combustion, if you remember last time we did combustion balancing, if it's in 2 places like the oxygens are, try to ignore them and see if they balance themselves out. So we're going to focus on carbon and hydrogen and kind of go back and forth with them until the oxygens just kind of tend to balance. So carbons. I have 2 on the reactant side. I need 2 on the product side. So I find where carbon is. What do I need here? 2, correct? But that doesn't just change my carbons. It changes my oxygens. 2 times 2 is 4, so this number changes to a 4. I have a total of 5 oxygens. Okay. So carbons are balanced. Let's do hydrogens. Here. So I need 3 here. 3 times 2 gives me 6. That's also going to change my oxygens. What are my oxygens going to be? 1 will change to a 3, so 3 plus 4, 7. So my oxygens are the only things that aren't balanced. Okay, and I said we want to try to ignore them if we can. Is there any number I could put here, though, that might make me have 7 on this side before I ignore them? So if I put a 2 here, what does that do?
Make that 4.
This would be 4, and I would get 5. So that's not going to work. But I could put a 3 here. So what I'm doing is I'm just upping this to see if I can get somewhere near 7. If I can't, then I'll go back and start adding more. So what would be the next number I'd want to try after 2? 3, because you only want to go in 1 increments. 3 times 2? 6. 6 plus 1, that should be 7, right? 7, 7. So now it's balanced. 2 carbons, 2 carbons. 6 hydrogens, 3 times 2, 6 hydrogens. We have 6 oxygens here, plus 1 is 7. 4 oxygens here, plus 3 is 7. Okay, so balanced chemical equation. Now we can actually answer the questions. All that work, we can actually answer it now. How many atoms of oxygen and how many atoms of hydrogen on both sides? Well, we already answered that when we balanced it. How many hydrogens? 6. How many oxygens? 7. Okay, and to be sure, we said you need to take the coefficient times the subscript. Okay, well, hydrogens, coefficient 1 times subscript on hydrogen, 1 times 6, 6 hydrogens. For oxygens, coefficient 3 times the subscript of 2. That gives me 6, but there's also 1 over here. So I add 1 more to that for 7. Okay, so balancing the equation itself actually gives you the atoms of each. So it's kind of nice when it asks you to do that because you're already solving for it in the process. Time for one more. All right, so let's try number 2 now. Looking at number 2, just for fun, what type of reaction are we looking at number 2?
Combination.
It is a combination. So we have, they give us a balanced chemical equation. And we have 2 reactants combining to make 1 product. So the type would be combination or synthesis. They mean the same thing, just depends who's doing the asking. This question is asking for moles. So now we want to look at the types of mole problems we have. Well, the type of mole problem that we're looking at right now gives us a balanced chemical equation. Okay, so it's not giving us a gram amount, it's not giving us an atom amount. It's giving us a balanced equation. So with a balanced equation, when you're figuring out moles, you're going to be looking at the coefficients. Somehow. Possibly, most likely, in a mole ratio situation. So, balanced chemical equation, coefficients represent the moles. So I have 1 mole of N2, 3 moles of H2, producing 3 moles of ammonia. So now let's look at exactly what the question's asking for, so we can figure out which coefficients, which molar amounts we need to look at.
Why is it a 3?
Did I just wrote it wrong?
Oh.
Because it's Friday and I'm off my game, 2 moles of H3. And that's why I have you here. So that you can correct all my mistakes for me. Okay, so the question is asking, correct me if I'm wrong, the question is asking how many moles of nitrogen gas. So we're going to be looking at nitrogen, are needed to react with 1.5 moles of hydrogen. So the reason I'm putting squares around these is because when they ask us for moles and they give us a balanced equation, we're most likely going to use a mole ratio. We're going to compare 2. So these are the 2 that they're asking us to compare. All right, now, how many moles are needed to react with 1.5 moles of hydrogen to form 1 mole of ammonia? Okay. That 1 mole of ammonia really isn't going to matter. That's why I didn't circle that one. So, we need a mole ratio to figure this out. Now, what they're saying is, we're starting with, it's 1.5 moles of hydrogen. Is that right?
Mm-hmm.
And they're saying, how many moles of nitrogen are we going to need? So we're going to use the coefficients to figure that out. Because if I had 3 moles of hydrogen, it would mean that I need 1 mole of nitrogen. They're saying, okay, you don't have 3, you have half that. So if I have 1.5, half of that, how many moles of nitrogen do you think I need? Half of 3 is 1.5, half of 1 would be 0.5. So you could look at it logically like that, but we don't always get half of something. So when we actually solve it, to do it, we start with the moles that they give us, and what we put here is the mole ratio of the 2 we're comparing. And we're gonna get the same answer, we're just doing it systematically. So the mole ratio, we use the coefficients, it is 1 of N2 is equal to 3 of H2. So we want to put the 3 on the bottom because we're trying to cancel out the hydrogen. We're trying to figure out how much of the nitrogen. So we get 1.5 divided by 3, which is 0.5. So when we look at a problem like this, when it's easy enough to solve in our head, when we're just doing halves or thirds or something, we can figure it out and we're actually using this logic without realizing it. So that's a mole ratio problem based off a balanced chemical equation. All right. For number 3, I'm probably going to start number 3 on Monday because that's a predicting products and balancing the chemical reaction, and it just gives us the chemical names, so we're going to have to convert those into formulas. So this one's going to take a good 10 minutes. But we'll have plenty of time to finish the rest of the problems. So we just have 3 through 9 left to do. This, along with the practice exam, are the best ways to study. So I wouldn't just do the practice exam and be like, oh, I did good on it, I'm going to get 100 on the test. No, do the practice quiz that I put up. That is a Blackboard quiz. It's not worth points, but I want everyone to try it because that's the formatting, and those are, I think it's only like 2 or 3 questions. It's a very short quiz. Those are, is it 5? It's the exact formatting that you'll see on the exam. The exact type of questions with different numbers inserted. So I don't want you to get to the exam and be like, what are they, I don't want you to have any questions about formatting, like people have been with the homework questions. I don't want that to be the reason you don't get a good grade.